Hi everyone and welcome to lesson 6, solving quadratics using the difference of two squares method. That's basically our focus question for today. How can we factor using the difference of two squares method? So today's factoring method is going to involve perfect squares and taking the square root. But before we dive into our new method, we're just going to review the product sum method from lesson 5. So I'm gonna use the steps in my head, but you should have the steps written down from the last lesson on how to factor using the product and sum. So your first step, we're just gonna review this together, is to write down your A, B, and C values. So our A is 1, our B is positive 5, and our C value is negative 24. So that's step 1. The next step is you need to list your factors of, okay? So now that your C value is a negative number, that means you need a positive and a negative number that will multiply to a negative. So we could have either 1 and negative 24 or negative 1 and positive 24. It could also be 2 and negative 12 or negative 2 times positive 12. Here we have a few different options, 3 and negative 8, negative 8 and 3, and am I missing? Oh, 4 and negative 6, and negative 6 and 4. So I have all the factors listed that multiply to, remember these all multiplication, negative 24. So now our next step, now that we have all our factors listed, our next step is to see which one adds to our B value. So our B value is positive 5. So if I go back to our factors from step 2, this looks like 6 equals 5, so let me change that. So our B value equals to 5. So let me see. So 1 and 24, we can't get 5. So I'm just going to cross that out. 2 and 12, we can't also add to get 5. 4 and 6, nope. Okay, so let's look at 3 and negative 8. 3 plus negative 8 is negative 5. So that's no good. But negative 8, oh, this is supposed to be positive 8 and negative 3. Yep, so positive 8, sorry, and negative 3 is going to work because we have 8 plus negative 3 equals to positive 5. So those will be our factors. Sorry about that before. I wrote negative 8 twice. So just to clarify so no one gets confused, this was supposed to be negative 3 times positive 8, which is the one we had to use, which adds to positive 5, which is our B value. Okay, step 4. So let's write out our factors. So we know it's x plus 8 times x minus 3. So this is the factored form of this, equals to 0. And then we just need to set both of the factors equal to 0 to solve. So we have x plus 8 equals 0, and x minus 3 equals 0. Subtract 8. X equals to negative 8. That's one of your solutions, roots, zeros, anything you like to call it. Here we add 3 on both sides, and we get x equals to positive 3. So again, you can graph this function into Desmos or your graphing calculator and see that the parabola is going to hit the x-axis at negative 8 and positive 3. Okay, so now going on to our next method, which is the difference of two squares. So what do we talk about? So I'm not actually talking about a physical square like in geometry with 4 sides, but I'm talking about a number that is made by squaring a whole number. So some examples of a perfect square are 16. 16 is a perfect square because 4 to the second power equals 16. 4 times 4 is 16. Also, 25 is a perfect square because 5 squared equals to 25. So I'm just going to list down all the perfect squares. So 1 to the second power is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 to the second power is 36, and all of these numbers here are perfect squares, okay? So you're taking a whole number, squaring it, and the result are perfect squares. So 1, 4, 9, 16, 25, 36, 7 squared is 49, and you could keep going. So all of these are perfect squares. No flaws. Okay. So a square root. So square root of its value is a value that can be multiplied by itself to give you that original number. Okay, so for example, the square root of 9. The square root of 9 equals to positive and negative 3 because 3 times 3 equals positive 9 and negative 3 times negative 3 equals positive 9. Okay, another example is the square root of 16 would be positive and negative 4 because 4 times 4 gives you 16 and negative 4 times negative 4 gives you 16. Okay, another example is square root of 25 would be both positive and negative 5. All right, so with this in mind, we're going to go into how we do the difference of two squares method. So just a little investigation here before we get into it. Find the product of the following three examples. So if you notice here, I'm just going to do two examples, okay? I'll sake of time. I know you guys have a lot of work to do. Let's just write out the product of this. So if you notice, we're multiplying these two binomials together, and the 5s have opposite signs. So let's see what the outcome is. So x times x is x squared. X times negative 5 is negative 5x. 5 times x is plus 5x. And 5 times negative 5 is negative 25. So here, if you can see, the negative 5 and plus 5 become 0. So we're just left with x squared minus 25. Okay. And here, we're going to do the same thing. X times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. And negative 2 times positive 2 is negative 4. So again, here, the positive 2 and the negative 2 eliminate to 0, and we're left with x squared minus 4. So these are our results. So what do you notice about the factored form and the product? Well, if you take a look, the product becomes a binomial, right? It only has two terms. And another thing I want you to notice is that here, the square root of 25 is positive and negative 5, okay? The square root of 4 is negative 2 and positive 2. So this is basically how this method is going to work. So today's method is going from our expanded form back to our factored form. Okay, and that has to do, of course, with taking the square root. Okay, so let's go on to our examples. All right, so I have the steps listed out for you. So difference of two squares. I like to call them dots. And in order to factor our binomial that is a difference of two squares, follow the following steps. So we're going to follow these 4 steps. So factor out the GCF if needed. So if you notice, this is called the difference of two squares because this method only applies to when there's subtraction, okay, between a binomial. So difference means subtraction, right? So if there's an addition sign, you cannot use this method. So that's first step. So let's look here. Here we have x squared minus 25 equals to 0. So first step says to factor out the GCF. So here, x squared and 25, there's no greatest common factor. So we can skip to number 2. So we're going to take the square root of both terms, okay? The square root of x squared is x, because x times x gives you x squared. And the square root of 25 is positive and negative 5. Okay, with that being said, we're going to move to step 3, which is to set up the two binomials using an addition in one and subtraction in the other. So x squared minus 25 is going to become x plus 5 times x minus 5. And we're going to keep that equal 0 because we're solving for the solutions. And now you know how to solve for the solutions by now. Okay, you just take each factor and set it equal to 0 and solve. So minus 5, x equals to negative 5, plus 5, and x equals to 5. So those are your solutions. So mainly, you just have to write out your binomials and put the square root of that number in here. All right, let's move on to our next example. So here we have 9x squared minus 4. All right, so let's look at number 1. Is there a GCF here between 9 and 4? Nope, there's no GCF. So next step, it says to take the square root of both terms. So square root of 9x squared is 3x, okay? Because 3x times 3x is 9x to the second power. Remember, you add your exponents. 3 times 3 is 9, right? That's the square root of 9. And the square root of x squared is x. And the square root of 4 is positive and negative 2. So let's do step 3 and set up the two binomials. So one's going to be 3x plus 2, and the other one's going to be 3x minus 2 equals to 0. Lastly, we just solve for x. Here's a little more, intense, not really intense, but a little bit more work to solve because you have a coefficient. I hate this thing. You have a coefficient in front of x, so let's write this out. So we have 3x plus 2 equals 0, and 3x minus 2 equals 0. Here we're going to subtract 2 on both sides first. We got 3x equals to negative 2, and divide by 3 on both sides. And yes, it's a fraction. That's perfectly fine. Just leave it like that, negative 2/3. So that's one solution. Here we're going to add 2 on both sides. We get 3x equals to 2. And this is going to be positive 2/3 as the other solution. And that is it for this lesson. You're going to work on the practice, and I'll see you for the lesson, I think it's 7. Have a good day.